Welcome back, everyone. We are doing our first lesson on our unit on proofs. And the first lesson is going to be about inductive reasoning, which is us trying to get a sense as to what is going on and why. So, a quick definition of inductive reasoning is you making observations. So first, in all of these examples that we're going to do, is you're going to observe first. So you're going to make an observation, try to see what's going on in your brain, and then you're going to make a conjecture based on what you know. So this is why it's kind of difficult, this unit, is because we all have different perspectives coming in to this class. We all come from different backgrounds, and so it's difficult sometimes to work on this unit because we all may be thinking about different things, and just because we have different observations doesn't mean that we're wrong. So, again, inductive reasoning, observing, making a conjecture from the evidence that we have. Now, I hope that we know what conjecture means. Okay, conjecture, just in case you don't know, is kind of like a hypothesis. So that's what we're working on today, is hypotheses, working on, well, what happens if this happens and what happens if this happens, taking a look at evidence. All right, so let's go to some examples of what it might look like. So let's say you may have a problem that gives you a list of numbers. So let's say we have the list 1, 2, 4, 7, 11. And they want you to figure out what is going to be the next number in this list. So we have to make a conjecture based on the evidence that is given to us. So here we look at 1 and 2, and we go from 1 to 2, we add 1. When we go from 2 to 4, we add 2. We go from 4 to 7, we add 3. 7 to 11, we add 4. So what do you think is going to happen for the next number? Hopefully you're thinking we're going to add 5, so the next number is 16. Okay, we could do the same thing without numbers. You could have a different pattern. You may have A, B, B, C, C, C. So what do you think the next pattern is going to be? Hopefully you're thinking, okay, the next letter in the alphabet is D. There was 1 here, 2 here, 3 here, so there's hopefully going to be 4 D's in this row. Okay? And one more thing that could happen, again mathematically, is let's say they ask the sum of 2 negative numbers is going to be what? Okay, and you think to yourself, you're going to go and you're going to think of examples. Okay, -1 plus -2, what's that going to give me? A -3. Okay, what if I did some bigger numbers, like -10 plus -4? I'm going to get -14. So what always happens with 2 negative numbers when you add them together? You're always going to get a negative number, because negative plus negative is still a negative. Okay, these conjectures are just simple one-answer conjectures. And these are kind of easy because there is only one correct answer. Where it becomes a little more tricky is when you have to have an answer, but there could be more than one. So again, what we just did was we looked at just one-answer problems with conjectures. Now we're going to look at things that have more than one answer. For example, let's take a look at this picture. If you look at this picture, it's in different perspectives. Some of you may be thinking, oh, I see that there is a girl's face right here. And here's her bangs, and she's got a hat on, and she's got a little fur coat right here. Some of you may be looking at the other perspective on the right side and see this big honking nose of some dude who has a mustache, and he also has a hat on. So it depends on the perspective that you're looking on. So the next examples that we have, I'm going to give you 2 of them, is going to have more than one correct answer, but it's all about your perspective. Doesn't mean it's wrong, just means that we may have different perspectives. So for example, what if I said I was late to school? Okay, if you heard that reasoning, you could say a lot of different things. Why were you late to school? Was the bus late? Did you wake up late? Did you get attacked by a rabid squirrel on the way? Did you accidentally fall and break a leg outside and so you couldn't get to school? So the idea here is that I was late to school has more than one answer. We don't know which is the correct one, so we would have to test our theory or test our hypothesis. But there is more than one correct answer for I was late to school. Okay, here's another example. And you can write down whatever you want right here as to why I was late to school. There's more than one answer. Let's say that you saw a picture like this, and we're throwing this back, and you had all these points right here, and I asked you to make a conjecture based on this statement. There's a lot of different things you could say. You could say, I know that angle NEO equals 90 degrees. Okay, that's true. I know that angle NEL plus angle LEO equals 90 degrees. So part plus part equals whole. I know that angle LEO is acute. So see, there's a whole bunch of things going on here, and that's okay. We all have different perspectives. You could say angle LEO equals 30 degrees. Does it? We don't know. It could. It's a hypothesis. We could prove it right or wrong later. So this is an idea of how you're making conjectures, how you're deciding, okay, is this true, is it not true, is it something that could be right, could it not be right? You're just trying to brainstorm. And so this is where it becomes difficult because there's more than one right way to do it. Okay, next, last thing. So here's where we're going to take the next road in our next lesson. So if we have a conjecture, it is true or it could be false. We have to prove it. So if it's true, that's where we're going to learn how to do proofs. And we're going to learn about that later because it's a little bit more grown. But if it's false, we have to provide a counter example. And that's exactly what it means. It's an example that would prove that it is, in fact, false. So a counterexample proves that it's false. Okay, so for example, let's take a look at what you might see on your homework. So let's say that you had something that said all students from Messmer were born in Milwaukee. Now we know that that's not true. It could be true in some cases, but it's not true in all. So since it's not true in all, this is not a true statement. So this would be false, and a counterexample would be, well, I don't know, let's say Anna was born in Racine. Okay, or maybe you yourself were born in Illinois, or you were born in Georgia or California. So this is a counterexample right here, is an example that proves that this statement is actually false. So here's one that's more related to math. So if I said that if I had an acute angle, so if there is an acute angle, then it is 45 degrees. Is that a true statement? Well, acute angles can be 45, but are all acute angles 45 degrees? No. What could an acute angle be? Anything less than 90. So it could be 46, 47, 48. So it can be anything less than 90. So you could say that it is 80. This is a counterexample. Okay, one more just to make sure you understand. Two adjacent angles form a linear pair. So if I had two adjacent angles, do you remember what adjacent means? Adjacent means that they're right next to each other. So if I have two adjacent angles, they form a linear pair. You remember what linear pair means? Linear pair means that they form a straight line. So these two angles right here are next to each other, they form a linear pair. So the question is, if two angles are next to each other, do they always, every single time, form a linear pair? The answer is no. And I can just draw it a different way. I can show right here. These two angles are adjacent, but they don't form a linear pair. So this is a counterexample.